Welcome to the next video in the GRE Math Subject Test series. In this video, we're solving problem number 6. So this one asks us, which of the following circles has the greatest number of points of intersection with the parabola given by that? And I think obviously we'd want to say, to sort of rearrange this. Okay, and if we look at all the answer choices, then clearly we've got circles centered at the origin. So let's graph this, right? So we know that 4 is down here where the vertex is. The graph looks roughly like this. And we're taking intersections with circles. So if we pick a small circle, that'll be 0. We could maybe pick a big enough circle, I'm going to guess, where you could have 2 points of intersection. But it certainly also seems like you could take a big enough circle maybe to hit, 4 points of intersection. But if you went really big, you'd only hit 2. So I'm going to guess that it's an intermediate value, even if I don't already know. Right, like, so I'm going to say it's almost certainly not 1. In fact, right, I think we can clearly tell that, like, if this distance is 4, and, we could ballpark how far away I guess not even ballpark, 2 and -2, right? So a radius of 1, no good. Now, but anyway, okay, enough with the qualitative analysis. I think our target is to find 4 points of intersection, but then the question is, which of these accomplishes that? Let's actually write down that we're going to be talking about x squared plus y squared, but because we want points of intersection with this line, we could substitute y and talk about x squared plus, what is that? X squared minus 4 squared. And, certainly the question is simply, what is this going to be set equal to? I think we can already start to see where the number 4 is going to come from, because we're going to have a 4th degree polynomial. So this is going to get us x to the 4 minus 8x squared plus 1, so minus 7x squared, and then what, plus 16? So let's say that this is then equal to, I don't know, k, where k is just going to be one of these values that we haven't yet decided on, although I'm guessing not 25. But in any case, then let's say, okay, so we're trying to solve this for 0, so let's then say that, let's make a substitution. Let's say that z is x squared, so that we're talking about z squared minus 7z plus, and then this number 16 minus k, all solving for 0. Now, we would like there to be, especially because of how z looks, right, we're going to get 2 distinct solutions for x if we can find a positive solution for z. So we want, in fact, two positive solutions for z. Now, if we want 2 positive solutions for z, then let's just throw everything immediately into the quadratic. And in the quadratic, we would get that, what we're talking about, 7 plus minus square root of b squared, which is 49, minus 4a, which is 1, times c, which is this 16 minus k, and all over 2. Okay, but most of this we can ignore. I think the main thing that we want to observe is we want 2 positive solutions for z, right? This is z. Now, if we want 2 positive solutions, one of them is positive for free because of the plus, but then we want the minus, right, the thing that corresponds to the minus, to also be positive. So effectively, I want this square root value here to be greater than 7 strictly, or sorry, less than 7 strictly, which is to say that I want everything underneath the square root to be less than 49. So I want 49 minus, what is that, 64 plus 4k. I want this to be less than 49. We could just cancel out the 49s, add over. I want k, and And not only do I want this to be less than 49, but I also want it to be greater than 0. But in any case, let's just, rather than write that out, let's say that I want 4k less than 64, which is to say I want k less than 16. So I think if I set, right, so my answer is C, because in C, the value of k, which was this value over here, is less than 16. Probably I don't want to, and that would come from saying that I want the thing underneath the square root to be strictly greater than 0, because that would guarantee me two strictly positive square roots. And so I'm betting. And actually, so I would already have made my decision because I think that, this choice of k, where k is equal to 9, would get me something that satisfies what I already said I want, and I would also probably have something positive underneath the square root, getting me 2 solutions for z, and then 4 solutions for x. But, and so I'd already have made my decision and moved on, because my instincts here sort of tell me that that's probably correct. But if I want to really work it out, just to make sure that I'm really right about this, then I probably also want to say that 49 minus 64 plus 4k, I also want to be strictly greater than 0. And so now if I do that, I'm going to look at 64 minus 49. What is that? So I guess that's like a 5. 1, 5. So then I know that what I want is for 4k to be greater than 15. And in that case, k should be greater than 15 over 4, which, what can I say about 15 over 4? I know that it's slightly, it's slightly less than 16 over 4. 16 over 4 is 4. So I want something bigger than 4, right? Roughly speaking, right? Larger than this number, but by an approximation, I can just say 4. And 2 does not count, right? 2 is not going to cut it. 2 is too small. K, right? If k were chosen to be 2, then this inequation would not be satisfied. And so I know I can rule out 2 and rule out 16. So 9 is my choice. If you appreciated this content, please like and subscribe. And if there's anything that we discussed here where you'd like to see it elaborated further, I might be able to answer questions in the comments, or for substantial topics, I might make an entire video and add it to the playlist.